And as x goes to positive infinity, that means it's going to the right, then the function's going up. And finally, if it's odd-powered with a negative coefficient, are you seeing how this chart's working? It's just like this describes the coefficient, this describes the power. It might look something like this. As x goes to negative infinity, this function goes to positive infinity. And as x goes to positive infinity, the function goes to negative infinity. So what's my hope? My hope is that without a graphic calculator, you know kind of what the function looks like. And we are going to confirm with our calculator. First of all, sometimes we do crazy things and we don't put things in the right order. So always check that the highest degree term is first. So in this one, 3x to the 6th, that is the highest degree term and it's first. So that's what we're looking at. This stuff here, it changes intercepts. It changes how many extrema or maxes and mins there are, but I can still tell the end behavior. I know that this might do a bunch of stuff in here, but I do know that the ends are going to look like that. Does that make sense? Okay, so if I asked us to describe the end behavior, I would write the limit as x goes to negative infinity of f of x equals infinity. And the limit as x goes to positive infinity of f of x also equals positive infinity. Okay, would you guys pull this up on your graphing calculator now? Okay, so we kind of got some weird stuff going on in there. That's what I got. That's not what you got? Yep, do zoom 6 to get it back to a standard window. All right, let's look at the next one. So I'm just going to double check that this is in standard form. So the highest degree term is listed first. This is an odd power and a negative leading coefficient, so that tells me that's going to look like this one. And again, I don't know exactly what it looks like in the middle, but I know it's ends. So we're going to write the end behavior, the limit as x goes to infinity of f of x. Oops, I should say negative infinity first to stay consistent. So that means as x goes to the left, the function goes up. Then as the limit as x goes to positive infinity of f of x, the function goes down. So we would say negative. And just a note, is anybody in here maybe going to take calculus ever? Okay. So technically in calculus, we say a limit has to reach a number and infinity really isn't a number. So sometimes in calculus we would say it does this, but then we'd say the limit doesn't exist. So infinity is one of those things that it does help us start going, but it never gets to infinity. I would like to have done this before. It's if it's a quadratic. Is if you can pull But this thing, do you see how they both have an X in them? So what I'm going to be able to do is I'm going to be able to pull that X out to the front. And then I'm going to get a quadratic. Okay. I'm going to keep going. This is one of those differences of squares. So this factors into x plus 4 times x minus 4. And we set that equal to 0. And don't forget about that little x guy in front. That really means x minus 0. We just don't write that out. So this has 3 zeros, or 3 x-intercepts. What are they? -4, 4, 0. So what that means on the graph, and this is what we're going to get to on Monday, is if I know the end behavior, I know, hey, it goes like this. And now I know where it crosses, I can do a little bit better job of sketching a picture because I can see where it crosses the axes and I can describe its shape. So in your mind, kind of picture what this looks like, and let's confirm with our graphing calculator. X cubed minus 16x. And that's what probably we thought. What's going on here? It's just going up higher somewhere. I don't know where, coming back down. Maybe if I zoomed out, I could see it. I'm going to just change my y's. I don't need to change my x's. I wanted to do 50, not at. There. Okay, we're going to talk about one last little thing before I give you a few problems to do. And I know you talked about this last year. Did you guys do the roller coaster problem? Did you do the roller coaster thing last year for polynomials? The roller coaster project? No? Sometimes, were you, oh no, you weren't in Stoughton. Were you in Stoughton? And you didn't do a roller coaster project? That not you can recall? Okay. So, zeros that have these powers here, what they do is they have interesting behavior at the x-axis. If it's an even power, the 0 touches and it bounces off. Is this sounding familiar to you? No? All right, let's just take a look at letter A so you can kind of see what it does. We'll take a look at letter B on Monday. So this is already factored for you, agreed? What are the zeros? X equals 0. Technically, this is a degree of 1, right? So we would call it a multiplicity of 1. I know that sounds kind of weird. The multiplicity is just how many factors there are. There's only one factor of x. This one would be x equals 3, right? But how many factors of x minus 3 are there? 2. So we called this multiplicity of 1 because there was just one factor. Because of that power 2, that's got a multiplicity of 2. Let me show you what happens when it's got a multiplicity of 2. Ooh, I gotta change my window again. Do you see at 0, this crosses the axis that goes through? Okay. What happens at 3, though? It bounces, okay? And so when factors have an even multiplicity, they are going to bounce off the x-axis and come back up. They're not going to have a sign change. They're not going to go through. And when they have odd multiplicities, they are. So that's just one other piece of information. On Monday, we're going to do a bunch of sketching by hand from what we've learned. Okay, but that's one other piece, even and odd multiplicity. So let's write at a 0 with even multiplicity, the graph of the function will bounce. So it's not going to cross the x-axis. There will be no sign change, meaning if it's positive, it's going to hit 0 and it's going to stay positive. And a 0 with the odd multiplicity, the graph of the function will go through the x-axis or cross it.